Hello everyone, I am Sindhu studying in Sri Venkateshwara College of Engineering, 7th SEM EC. Today I am going to discuss about a topic called OSI module and TCP ISP module. Let's begin the session. What is OSI model? OSI stands for Open System Interconnection. It was developed by a ISO, International Organization for Standardization, in, in the year 1984. It is a seven-layer architecture with each layer having a specific functionalities to perform. All these seven layers work collaboratively to transmit the data from one person to another across the globe. The OSI model created in 1984 by ISO is a reference framework that explains the process of transmitting data between computers. It is divided into seven layers that work together to carry out specialized network functions, allowing for a more systematic approaches to networking. We can see the seven layers architecture in this below diagram. What are the seven layers of the OSI model? The OSI model consists of a seven abstraction layers arranged in a top-down order. First one, physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and at last, application layer. Next, discuss one by one the layers. First one, physical layer. It is a layer 1. The lowest layer of a OSI reference model is the physical layer. It is responsible for the actual physical connection between the devices. The physical layer contains the information in the form of bits. It is responsible for transmitting individual bits from one node to the next. Functions of the physical layer: bit synchronization, bitrate control, physical topologies, transmission mode. Next layer, data link layer. It is the second layer. The data link layer is responsible for the node to node delivery of the message. The main function of this layer is to make sure data transfer is error free from one node to another over the physical layer. When a packet arrives in a network, it is the responsibility of the data link layer to transmit it to the host using its MAC address. The data link layer is divided into two sublayers. It is a logical link control and medical access control. The packet received from the network layer is further divided into frames depending on the frame size of network interface card. Data link layer also encapsulate senders and receivers MAC address in the header. The receiver's MAC address is obtained by placing an address resolution protocols request onto the wire asking who has that IP address, and the destination host will reply with its MAC address. Functions of the data link layer. First one, framing, physical addressing, error control, flow control, access control. These are the functions of the data link layer. First, here we have a network layer to data link layer. Here we have a communication is packer, and between data link layer to physical layer we have a frames. Next, it is a network layer. It is a third layer. Third one, it is a network layer. The network layer works for the transmission of data from one host to the other, located in a different networks. It also takes care of packet routing, selection of the shortest path to transmit the packet from the number of routines available. The senders and receivers IP addresses are placed in the header by the network layer. Functions of the network layer is routing and logical addressing. Fourth one, it is a transport layer. The transport layer provides services to the applications layer and takes the services from the network layer. The data in the transport layer is referred to as a segments. It is divided into a segments. It is responsible for the end-to-end delivery of the complete message. The transport layer also provides the acknowledgement of successful data transmission and retransmits the data if an error is found. At the sender side, the transport layer receives the formatted data from the upper layer, performs a segmentation, and also implements a flow and error control to ensure a proper data transmission. It also adds a source and destination port numbers in its header and forward the segmented data to the network layer. Functions of the transport layer is segmentation and reassembly, service point addressing. In that we have two layers: connection oriented service and connectionless service. Next, session layer, it is a fifth layer. This layer is responsible for the establishment of connection, maintenance of sessions, and authentic and also ensures security functions of the session layer. Functions of a session layer. Session establishes maintenance and terminations and synchronization and dialog controller. For example, let us consider a scenario where a user wants to send a message through some messenger application running in his browser. The messenger acts as the application layer which provides the user with the interface to create the data. This message or so-called data is compressed or encrypted if any secure data and converted into bits, zeros and ones, so that it can be transmitted in a communication in session layer. Here we have a sender or receiver. Sender sends the message to receiver which it is in a encrypted mode. That is called a session layer. Presentation layer, it is a sixth layer. The presentation layer is also called as a translation layer. The data from the application layer is extracted here and manipulated as per the required format to transmit over the network. Functions of the presentation layer is translation. For example, ASCII to EBCDIC, encryption and description. Data encryption translates the data into another form or code. Application layer, it is a seventh layer. At the very top of the OSI reference model stack of layers, we find the application layer which is implemented by network applications. These applications produces the data which has to be access the network and for displaying and receiving information to the user. Example application, it is a browsers, Skype, Messenger, etc. Functions of application layer, it is file transfer, access and management and mail service and directory services. These applications provides a distributed database source and access for global information about various objects and services. Next topic we are going to discuss about TCP or IP model. TCP or IP model was designed and developed by the Department of Defense, it is called as DoD, in the 1960s and is based on the standard protocols. It stands for a Transmission Control Protocol or Internet Protocol. The TCP or IP model is a version of OSI model. It contains a 4 layers. Unlike the 7 layers in the OSI model, the number of layers is something referred to as a 5 or 4. Here in the article, well, study of 5 layers: the physical layer, the data layer, and referred to as a one single layer as physical layer or network interface layer in the 4 layer interface. How does the TCP or IP model works? Whenever we want to send something over the internet using the TCP or IP model, the TCP or IP model divide the data into packets at the sender's end, and the same packets have to recombined at the receiver's end to form the same data. This thing happen to maintain the accuracy of the data. We can see the difference here. OSI module and TCP or IP model. Here we have in OSI model application layer, presentation layer, session layer, transport layer, network layer, data link layer and physical layer. In TCP or IP model, we have a application layer, transport layer, network layer and network access layer. In both we have a transport layer which make the communication between the sender and the receiver. We require a transport layer in both OSI model and TCP or IP model. For more, you can refer to TCP or IP in a computer networking layers of TCP or IP model. The diagrammatic comparison of TCP, IP and OSI module is we can see here. In this physical layer, it is a group of applications required network communications. In data link layer, the packets network protocol type in the case TCP or IP is identified by the data link layer. Internet layer, this layer parallelly the functions of OSI network layer. It defines the protocols which are responsible for the logical transmission of data over the entire network. It is the IP. IP stands for Internet Protocol and it is responsible for delivering our packets from the source host to the destination host by looking at the IP address in the packet headers. In this we have ICMP stands for Internet Control Message Protocol and ARP stands for Address Resolution Protocols. Fourth layer, it is a transport layer. It is same in OSI model and TCP or IP model. The layer protocol exchanges the data, receives acknowledgement and retransmit missing packet to ensure that packets arrive in order and without error. End-to-end communication is referred to as such transmission control protocol and user diagram protocol or transport layer protocols at the level UDP. UDP or TCP, the fifth one, it is the application layer. This layer is analogous to the transport layer of OSI model. It is responsible for end-to-end communication and error-free delivery of data. It shields the upper layer application from the complexities of data. The three main protocols present in this layer are HTTP and HTTPS. The HTTP stands for Hypertext Transfer Protocol and HTTPS stands for Hypertransfer Protocol Secure. It is a combination of HTTP with the SSL secure socket layer. It is efficient in cases wherein browse needs to fill out forms, sign in, authenticate, and carry out bank transactions. SSH stands for a secure shell. It is the terminal emulation software similar NTP stands for Network Time Protocol. It is used to synchronize the clock on our computer to one standard time source. Hope you understand these both topics on OSI model and TCP model. Thank you.